Hello guys, welcome back to Trendy Code Bytes channel. My name is Haraksh and in this video I'm going to explain distributed rate limiting in Spring Boot using Bucket4j and Redis with Java 17. Don't worry if you have never used Bucket4j or Redis before. I'll first explain the concept in very simple terms, build a clear mental picture, and only after that we'll look at the code. Let's start with a simple question. What happens if a client keeps calling our API again and again without stopping, without any restriction? Our server resources get exhausted, other users are affected, and the application can even crash. To prevent this, we use rate limiting. Rate limiting simply means we allow only a fixed number of requests from a client within a fixed amount of time. For example, 2 requests per minute per client. If the client exceeds this limit, we reject the request. Now forget servers, frameworks, and code for a moment. Imagine something very simple. Imagine that every client is given a bucket. Inside this bucket, we put tokens. Each token represents one allowed request. In our case, the bucket can hold 2 tokens. Now, imagine the client makes a request. Before the request is processed, we check the bucket. If the bucket has at least one token, we remove one token and allow the request. If the bucket has no tokens left, there is nothing to remove and the request is rejected. This is exactly how rate limiting works. Now, here's an important part. The bucket does not stay empty forever. After a fixed amount of time, new tokens are added back to the bucket. In our example, 2 tokens are added every 1 minute. So, pause for a moment and visualize this. A bucket, tokens inside it, request removing tokens, time adding tokens back. This is the token bucket algorithm. Bucket4j is a Java library that implements exactly this logic. Bucket4j creates the bucket, manages tokens, handles refilling, and decides whether a request should be allowed or blocked. Now comes a very important question. Where should this bucket live? The simplest option is to store the bucket in application memory. This works perfectly fine only if we have a single application instance. But in real systems, we run multiple Spring Boot instances behind a load balancer to handle more traffic. Now imagine this. A client sends 3 requests. Request 1 goes to server A, request 2 goes to server B, request 3 goes to server C. Each server has its own bucket in memory. So every server thinks this client still has tokens. Rate limiting is now broken. This is where Redis comes in. Instead of storing the bucket inside each server, we store the bucket in Redis. Imagine Redis as a central storage room. There is one bucket per client stored in Redis shared by all application instances. Now, when a request comes in, any server reads the bucket from Redis, removes the token, updates the bucket back in Redis. Every server sees the same bucket state. It does not matter which server handles the request, rate limiting is now accurate, consistent, and distributed. So now connect everything in your mind. Bucket4j manages the bucket logic, token consumption, token refilling. Redis stores the bucket, share it across all servers. Together they give us distributed rate limiting. In Spring Boot, we enforce this logic before the request reaches the controller. We do this using a Spring interceptor. The flow looks like this. Only if a token is available, the request reaches the controller. Now that you have a clear picture of what the bucket is, what tokens are, why Redis is required, let's move to the code and see how this exact concept is implemented step by step. Keep this mental image in your head while watching the code, because every line we write is implementing this exact flow. Now that we have a clear picture in mind, let's connect that picture directly to the code. I'll explain which class represents which part of the system so you never feel lost while reading the implementation. Let's start with the bucket itself. The rate limit service is responsible for defining what the bucket looks like. This is where we decide how many tokens the bucket can hold, how fast the tokens are refilled. In our mental model, this class represents the rules of the bucket. When we say 2 requests per minute, that logic lives inside rate limit service. Inside rate limit service, we define the bucket configuration. This configuration answers 3 questions. How many tokens can exist at once? How many tokens are added and after how much time? So when you hear 2 tokens every 1 minute, this class is where that rule is enforced. Now let's talk about who owns the bucket. In our mental model, each client has its own bucket. The rate limit interceptor is responsible for identifying the client. It decides which client is making the request and therefore which bucket should be used. In this example, we first try the X forwarded for header. Otherwise, we fall back to client IP address. That value becomes the bucket key. This interceptor is also where the gatekeeping happens. Every incoming request passes through this interceptor before it reaches the controller. Here's what happens. A token is requested from the bucket. If a token exists, the request continues. If not, the request is stopped immediately. This is the exact moment where a request is allowed or rejected with HTTP 429. Now, let's talk about Redis. Redis is configured inside rate limit config class. This class does not define rate limits, instead it defines where the buckets are stored. Think of this class as setting up shared storage room that we imagined earlier. The most important Redis related component here is the proxy manager. The proxy manager is the bridge between Bucket4j and Redis. When Bucket4j wants to create a bucket, read a bucket, or update a bucket, it does so through the proxy manager. We are using a CAS-based proxy manager. CAS stands for compare and set. This ensures that multiple requests hitting Redis at the same time do not corrupt bucket state. In simple terms, token updates are atomic and race conditions are avoided. We also configure Redis key expiration. Once a bucket fully refilled, Redis automatically removes it. This prevents unused buckets from staying in Redis forever. So Redis memory stays clean and efficient. The test controller is just a normal Spring REST controller. It has no idea that rate limit exists. This is important. Rate limiting is completely decoupled from business logic. If the request reaches this controller, it means rate limiting already passed. Now let's connect everything together. If a token is available, the request reaches the controller. If not, the request is rejected immediately. So whenever you look at this code, remember this picture. Buckets and tokens are logic handled by Bucket4j. Redis is storage shared across all servers. The interceptor is the gatekeeper and the controller only sees valid requests. Now that we understand the complete concept and how each part of the code fits into the mental model, let's see this working in real time. We'll do three things. Start Redis using Docker, run the Spring Boot application, and test the rate limit using Postman. First, we need Redis running because Redis is where our buckets are stored. I'm running Redis using Docker. You can start Redis using this command. Docker run -t --name Redis -p, which means port 6379 space Redis. This starts a Redis container on port 6379, which matches the configuration in our Spring Boot application. You can also run Redis using Docker Desktop. Make sure Redis is running before starting the application, otherwise rate limiting will not work. Now, let's start the Spring Boot application. I'm using Java 17, which is important because Bucket4j uses Java version specific modules. Once the application starts successfully, we are ready to test the API. Now let's move to Postman. I am calling the test endpoint /API/test/limited. This endpoint is protected by our rate limiter. This is the first request. The request succeeds because the bucket has available tokens. This is the second request. This also succeeds and now the bucket is empty. Now let's send the request one more time. This time the request is rejected. We receive HTTP status 429, too many requests. This confirms that tokens are being consumed correctly and rate limiting is working as expected. If we wait for 1 more minute and try again, the tokens are refilled and the request succeeds again. So what we are seeing here is exactly the mental model we discussed earlier. 2 requests are allowed, the third request is blocked, and after the refill time, requests are allowed again. I've shared the complete source code in the video description. Before running the code, make sure you are using Java 17, Redis is running preferably using Docker, and the Redis port matches the application configuration. That's it for this video. If this helped you understand distributed rate limiting using Bucket4j and Redis, please like the video and share it with others.